Hello everyone, my name is Michael from Polygon Island, and today I'm doing a tutorial explaining lighting and how you should do lighting in Blender. So lighting is one of those things that is just really hard to learn. It's really hard to kind of grasp and know how to do correctly and know how to make it look good. And lighting is also not a general thing. It's very much based on your scene, the composition of your scene, what you want in focus, and just everything like that. But in this video I'm going to be doing the best I can to explain how light itself works in real life, how colors react to it, and different stuff like that. So in Blender, you automatically, if you have the default startup file, you have a point lights. So what a point light does is it generates light from a point. It has like a radius around it, and it just generates light in all directions. It's not very good for focusing on one object. It's more focused on lighting up an area. How does that look by default? So if we switch over to cycles, I'm going to use cycles because it has more realistic shadows and lighting. I'm just going to put a plane under here and just go into render view. So if we go into render view, we can see by default we have this area light producing this kind of ring radius of light right here. We can see how this reacts to the cube. We can see that toward the front where the light is pointing down, the cube is obviously brighter, and toward the back where the shadows are, it's darker. What you'll notice is that we have this shadow right here, and now the shadow is very, very sharp. You can see there's a lot of sharp edges right here. It doesn't really fade out. That's because of the size of the light. If you have any light in real life also, you can test this in real life. If you have like a flashlight or something, get an object, shine a flashlight on it, and you'll have a very, very sharp shadow. That's just the size of the light. So in Blender, what you would do to fix this is just get a bigger light. That's also the same in real life. If you use a bigger light, it's going to have a softer shadow. So any kind of light will have this little light bulb icon down here. This is just your lighting settings. So you can also change which type of light it is in here, but we're going to get to that here in a little bit. But we can see we have the color of the light, the radius, how many bounces the light can have, and just different stuff like that. So in this case, the radius is the size of the light. So let's say we change the radius to 5. We can see that the shadow is a lot softer and is nowhere near as harsh. Now obviously this is a very extreme example because this is a very, very large light. But if we change it down to like 1 meter or something, we can see immediately the shadow is a lot softer. It kind of fades out through here. And that's how to get softer shadows. So now actual lighting. So there's a bunch of different lighting options you can do, but I'm going to go over basically 3 main ones, which are 3-point lighting, rim lighting, and just focus lighting. So right here, what we have right here would pretty much is what I call focus lighting. It's basically focusing on one part of the object, and that object is what is in focus. We can see that, let's say this cube, for example, we want the viewer to focus on these front faces right here. So something like this, and the back part's in shadow because you don't really want that in focus. That's what I usually use point lights for. So that's focus lighting. So now 3-point lighting setups are usually done with area lights. So if we change this to an area light, I'm going to go ahead and add a new one actually. To add a light, you just shift A and go down to light and then pick what light you want. I'm going to add an area light, move it up, and then just put it on the cube. So you can see it's very dim right now because the power is only at 10 watts. But if we change this to something like 5,000, not 5,000, that is a lot, but like 500, we can see that this is how the area light is. So we can see the area light. Anything behind the area light is in shadow because it's not shooting light from down here. It's only shooting light in one direction. You can also adjust the size for this too. I'm going to change it to 5 just to get a little bit of softer shadow right there. And to do 3-point lighting, it's very simple. You just put lights in 3 points. So I'm going to put this right here, and I'm going to put one toward, you put one on both sides basically, and then you put one behind it. So something like this. This is a 3-point lighting setup. and you can see it basically lights the cube from all sides. And if you want your model viewed from like all sides, a 3-point lighting setup is very useful. So that's that. You can see that we have light coming from all 3 sides right here. It's pretty much lighting up every face. You can also change the power of the lights if you want it brighter, obviously. The size, you can also change the in area lights. You can change the shape of the light. So by default it's square, but if you change it to rectangle, we kind of have bigger kind of little things. And if we turn back on our preview, we can see that this is now a rectangle. You can also change the X and Y size of the rectangle right here. We can change it to a disc, which is a circle, and we can change it to an ellipse, which is a flatter circle. It's an ellipse. I'm going to change this back to square for now. And now on to our different, our next lighting, which is rim lighting. So rim lighting is very good if you're trying to get a focus on the outline and the silhouette of your object. So I'm going to go ahead and change my world settings down to black for this. And what we're going to do is we're going to Shift A, and we're going to add a point light. We're going to put the point light behind the cube like this. We're going to change the color to about 500. And now if we go into render view from the front, this is a very bad example because it is a cube. I'm going to use a UV sphere. I'm going to give it a subdivision of 2. And if we look at it and we change the lighting to something a little bit more powerful and move the light up, we can see that we have this kind of rim light thing going on. You can also duplicate this and just have this cool little rim light effect. So this is rim lighting. So rim lighting is obviously lighting around the rim of an object. You can also change the color of these. So I'm going to change it to this kind of blue color because I think that'll look pretty nice. Just change all these to blue, and we can see now we have this nice little subtle blue lighting effect around our ring. You can also change different points of these. So you can change the color for each of these to get this really cool effect right here. So that's pretty cool. And now that's rim lighting. It basically lights the rim of your object. It gives focus on the silhouette of it. You could also change your metallic properties of your object to kind of get that cool glowing effect on it. So that's pretty cool. But obviously we can see what's going on back here is it's just shining light on the back and it's reflecting into the front. So looking from the front, or the opposite angle from where the lights are, we can see that it gives this rim lighting effect. So now on to how does lighting work in the real life. How does lighting work as a whole? So lighting in real life, I'm going to use Blender as an example for this because obviously I don't feel like recording in real life, but I'm going to go ahead and just put an area light with 1,000 and 1 meter, just like we had earlier. And now we have this. I'm going to change the material back to that, and I'm going to change the world color back to gray. So how does lighting work in real life? So if you don't know, light bounces. Light bounces off of everything that exists that you can see with your eyes. Light bounces off of. So in Blender, that's controlled by roughness values. But take a look around your room right now. Find a shiny object, something that's just shiny. That object is reflecting a lot of light. It's not absorbing much light, it's reflecting a lot of it because it's glossy, it's reflective, it's bouncing light off of it. Now take a look around your room again. Find something that is rough, like your bed or a mattress or just something that's not reflecting light. That object is also reflecting light. But the reason you don't see it as shiny is because that object is absorbing more light than it is reflecting. So, for example, right here, we can see that this object right here, it is not shiny, but it is still reflecting light. So, light reflectiveness, how much light it absorbs and how much light it reflects and how much it diffuses, is controlled by something called specular. Now, specular is just how much light the object absorbs. So a good way to show this is turning it to black. We can see black now. Even though this object is not shiny, it is still reflecting this light right here. But if we turn the specular all the way down, the object turns completely black. The object didn't disappear. The object is very much still here. We can still see the shadows. It's just not reflecting any light at all. If you've ever seen Vanta Black or Black 3.0 paint that absorbs like 99% light, it looks pretty much like this because it is absorbing 99% of light. And if we change this back up to white, we can see pretty much it's not really doing anything because it's still being lit, but it's just white. But yeah, we can see that even if we turn it to gray, we can turn the specular all the way back up, and it's still reflecting right here. But if we turn it all the way down, it's not reflecting any lights. So lights are very, very weird in the world, in our real world. Human eyes are very, very they can see when lighting is off, when lighting is wrong. That's why it's very important to have good lighting in your renders, because it's very easy for a human to pick up what doesn't look natural, what doesn't look realistic, because we're around it all the time. We see the real world, we see what should look like, we see what things should look like. And if you have like an outside scene that you're seeing like all the time in real life, and you have it in 3D and the lighting isn't correct or the lighting looks off, it's gonna look weird. And the thing about realistic renders is realistic doesn't necessarily mean it looks good. Realistic doesn't mean aesthetically pleasing, and realistic doesn't mean that you should try to copy what the real world looks like. So if you go outside right now, I guarantee you the lighting from the sun on the earth is not going to be aesthetically pleasing right now. In some cases it might be, but it's just not going to look aesthetically pleasing. It's just the sun, it gives lighting, it's alright. But you have to make lighting look a mix of natural and realistic along with aesthetically pleasing. Because you can go out in a forest and have all the have like an overcast with like the sun beaming down, and you have all these hard shadows coming from the trees. Everything's lit, everything's just really bright. That's natural, that is realistic because that's real life, but that's not aesthetically pleasing. That's not what you want to look at. So you need to have a mix of aesthetically pleasing and realistic in your lighting. So, I should also talk about materials and light bounces because that applies here too. So materials, a lot of people, they don't get this necessarily, but a lot of people just think of materials as stuff that you texture and what the object looks like. But in reality, the material is the entire package that tells Blender, or any 3D software for that matter, hey, this is how this object should react to light. This is how this object should reflect, diffuse, what specular value it has, what metallic it is, just stuff like that. It tells Blender how the object should react to light. So, obviously I've already given the specular example. This shows how much it absorbs light. But we also have roughness. So, if I turn it all the way to black and I turn the specular to like 0.5 or something, we can see that it's already reacting to light in a different way since we changed that specular value. We already knew that. I already did this in this video. And then we have roughness value. Roughness value is what I was talking about earlier, which is how much light it reflects. Specular is how much light it absorbs. Roughness is how much light it reflects. So if we turn the roughness all the way up, we can see that we have a very rough object. Now this still isn't removing the light absorption or adding more light absorption, because if we turn specular up, we can see it changes because it's not absorbing, or turn specular all the way down, we can see that it's not absorbing light anymore. So if I change this back to 0.5, we change it back up, actually, we can see that it's brighter because it is absorbing more light, even though it is still rough. So if we change this back down to 0.5, we change the roughness to 0. So we can see if we change the roughness to 0, it makes the object completely shiny, pretty much mirror-like. It's not exactly mirror-like, but it's reflecting most light in the scene. We can see in the southern hemisphere of the sphere, it's reflecting the plane that's around it. It's reflecting the shadow even back on itself. It's obviously reflecting the light. Basically, it is reflecting nearly all light that is coming to it. So if we slowly increase this, we can see that it slowly starts absorbing more light rather than reflecting it. We can see it's absorbing because of this little ring that's around this light right here. And what this ring around this light is called in lighting is diffuse. It's basically taking this light right here and kind of shooting it all different directions around it, like this. Imagine, the best way I can describe is, imagine over this light right here you have a pizza cut in eighths, or like just anything in eighths, where there's like 8 lines from the center. That's basically what it is. It's obviously not 8 lines, it's a lot more than that, but it's basically diffusing the light throughout this material. Everything diffuses light, it's just how it does. It bounces off of the object. Most light bounces off of the object, but I'd say take this with a grain of salt, because I don't know the statistics for this. I'm probably like completely wrong here, but you'll get the point anyway. Some light gets absorbed and diffused throughout the material, and then some light bounces off. So what diffusing light does is it basically gives light to other parts of the material. So when you shine a light on something, that light is not focused in one spot. That light is shining on multiple parts of the object at the same time. All connected, but it's multiple parts at the same time. That's what diffusing light is. It's just bouncing off, spreading throughout the object, spreading throughout whatever you're shining your light on. So if we keep cranking this roughness up, we can see that it's starting to diffuse more and more. It's starting to light up over through here. We can see if we turn it back down, we can see this was a lot blacker. And if we start doing it now, we're diffusing all through down here, all through up here, and stuff like that. We change it to 1, and it's basically diffusing the light throughout the entire material, because it's basically just diffusing the light. It's not reflecting the light anymore, it's absorbing it, it's diffusing it throughout the material, and stuff like that. So I'm going to change the roughness down to 0.5. And we also have this little thing called metallic. Metallic is the metallic properties of the object. So I'm mentioning this because metallic materials have a very, very weird way of absorbing light. Not just in Blender, not just in 3D, but in real life too. Because metallic materials are not necessarily reflective. So if we turn this all the way down, we can see that it turns to glass, basically. It's completely reflective, just like it was. And if we start cranking it up again, we can see that it's not diffusing light as much as it was before. It basically just has this sheen, has this metallic look to it. So metallic is a completely different property than any of these. It's a completely different way that a material absorbs and reflects light. If you look at metal in real life, you'll see that compared to any other material, it reflects light very weirdly. So if we just keep cranking the roughness up, we can see that it's diffusing light more and more. But there's just something about metal. I can't really describe it, but it's metal. It's the look of metal. A lot of times, if you're in a PBR workspace, like Substance Designer, Substance Painter, Quixel Mixer, you have different color options, different lighting options. It'll be like albedo and like metalness and stuff like that, because metalness has a completely different reflective value. So if you use, let's say you have a metallic object and a metallic material, and you switch your workflow from metallic to albedo, even though the object is metallic, the lighting is going to react completely different, because it's trying to use lighting that it would use for a diffuse albedo material rather than a metallic material. So that's what metallic is, basically. I'm going to change this back to 0.5. But yeah, that's pretty much lighting. So hopefully you guys learned something about lighting. If you guys did, make sure to leave a like, subscribe to the channel, and as always, my name is Michael from Polygon Island, and I'll see you guys next time.